Differentiability. A function is differentiable at a point x equals a, provided that the function is smooth at the point x equals a for some real value of a. Now, differentiability at a point simply means that the first derivative at that point exists or can be found. A function is smooth at a point x equals a, provided that, number one, the function is continuous at x equals a, so there are no breaks or gaps. And number two, that there are no sharp corners or cusps at x equals a. Now, if a function is continuous at x equals a, that does not necessarily mean that the function is smooth. However, if a function is smooth at x equals a, or any particular point for that matter, then that does imply that the function must be continuous at that point. Now, to show that a function is smooth at a point x equals a, number one, we show that the function is continuous at x equals a. So if it's a piecewise function, you need to check the value of the function on both sides of the join. And number two, we show that the gradients of the tangents on either side of x equals a, or any particular point of interest, are equal. Let's have a look at an example. Explain why f of x equals 1 on x, g of x equals absolute value of x, and h of x equals the cube root of x squared are not differentiable at x equals 0. I would invite you at this point, if you'd like to pause the video, you may graph these using any graphing software and have a look for yourself. Now, f of x is discontinuous at x equals 0. That's a hyperbola, there's a vertical asymptote, or the y-axis is the vertical asymptote, there's a clear break. So therefore, automatically, f of x is not continuous at x equals 0, therefore it's not differentiable. We cannot find the derivative at that point. Now, g of x, this absolute value function here, g of x is continuous, but has a sharp corner at x equals 0. So therefore, it is not differentiable at x equals 0. It's not smooth. Now, h of x is continuous, so similar to g of x, but has a cusp at x equals 0. Now, a cusp is a point that has a vertical tangent. So this is the graph of h of x. So this is the cube root of x squared. So just to show you what a cusp looks like, that's what it looks like there. So it's just at the origin there. And if you were to try and determine the gradient of the tangent at that point, it's in fact vertical. So therefore, we cannot define the gradient of the tangent at that point.